Hello everyone, this is just a quick suspended objects question. So if you would like to solve this problem, pause the video and then on pause to continue. So here we go. So we have this setup right here and we're asked to find the smallest angle of the rope that can make with the ceiling to support the beam. Okay, so what I've done here is that we want to support this 2000 kilogram beam, and however in a test that was done before that about on these same exact ropes, these ropes can only support up to 1750 kgs. Okay, so a mass of 1750 kgs was supported on them and the rope broke, so that is the max I could support. So we were asked to find the smallest angles, and those angles are exactly the same. Theta equals theta. Okay, so how do we solve this question? Well, first we draw a free body diagram. So let's see here. So here we have the big beam right here, and we said that this is big M, let's say. Okay, so what are the forces acting on it? Well, first you've got your T tension, and here you've got the other tension, and you've got your FG. Well, the FG should be bigger than this, so that's your FG. Okay, so that is your FG. So what does your FG equals? Well, your FG is just 2 kgs multiplied by G. Okay, I'm going to use 9.81 meters per second squared, and that should give me 9.81. That should give me 19620 newtons. Okay, so that is the that's the weight. That is the weight of that. Okay, and here we have the angle. So if you use the Z rule, we would know that this theta, using this Z rule, that means that this is theta. This right here is theta, and the same thing applies right here. Okay, so these two are my thetas right here and right here. Okay, so what do we next? Well, we know that the tension is equal to your T can hold up a maximum of 1750. So that's mass, we need to know kg, then we multiply this by 9.81. Multiply this by 9.81 meters per second squared. Why? Because that is the that is your FG for this FG2, let's say. Okay, and that is equal to the tension because it is the maximum that it could hold. So this FG2 is equal to the tension, and we need that tension. So what we do is multiply 150 times 9.81, and that should give us 17167.5 newtons. Okay, so now we know the values for these two. The last thing that we have to figure out is the angle, and that is the thing that we need to figure out. Okay, so we know that the tension, it's not equal to, but the tension has to be less than or equal to 17167.5 newtons. Okay, and so now what we could do is we could say, okay, the sum of all the forces on the y direction is equal to 0. Okay, so what we now have here, so we have here this going up, this is going up, so we have two of these, so we say that we have 2, okay, we have 2t sine theta, okay, because that's theta opposite over adjacent, and we have 2 of them, so 2t sine theta is going to equal to both of these. So this here and this here are going to be opposite of that. So they're going to equal to this because this is a suspended object question. So these are equal. So this is going to equal to 19620. Okay, newtons, of course. So what we do first is we divide by 2. So we got 19620 divided by 2. Okay, so we have the t sine theta is equal to, or yeah, so this is equal to 9810 newtons, and then we could substitute what we have for t. So this is going to equal to 17167.5 sine theta is going to equal to 9810 newtons. So this is also newtons, so when I divide, they're going to cancel out. I divide both of them, and then I have the sine theta is equal to 9810 divided by 17167.5. And that should give me 0.5714285.7. And then I'm going to take the inverse sine of both of these. This cancels out. And then I'm left with theta. So this theta is equal to, so I took the inverse sine of 0.57142.857, and that should leave me with 37.85 degrees. So that is going to be my answer for this problem right here. This is the smallest angle that we could make to support that beam that can have a tension that is less than or equal to this number right here. Okay, hope this helps. Thank you so much and have a good day.